Thank you so much for the opportunity. We'll be talking about Jido and kind of a talk that starts off as just a gentle introduction to this world that's just been, sprung up on the scene about autonomous agents and how to build them with Elixir. It kind of both covers the framework that I've been building, but also the history of agents and where they fit in the beam and all of that. So let me get my screen up here. A little bit about me. Background as an engineering leader and entrepreneur. I've worked mainly in the Chicago area and leading teams of various different sizes, and then started a company a while ago, and then got out of that in 2015 before I went back into the corporate world. But I've been involved in open source in one form or another for a long time, mostly in the JavaScript world early on. I came to know Elixir while I was at cars.com about 8 years ago, and was part of the group there that helped re-platform that entire stack to Elixir from a Java and Node.js microservices architecture. And you can follow me at the links, and I'll have those at the end as well. So as I said, this talk was kind of meant for anyone who has some Elixir experience, but no real agent experience. And so we're going to go over at the beginning what are autonomous agents, two ideas and kind of mental frameworks that I've used to wrap my head around and simplify when I'm working with agents and how I'm building with them, why I think Elixir is a really good runtime for those agents. And then we're going to get into Jido and the Jido framework, and then do some coding and live demos. Then we'll get to questions. So as you all have probably seen, agents are a big deal now. But the funny part is that agents are really kind of this old idea. Agents have been around in some form or another since the 1950s, where computer scientists really kind of came up with this idea of sense, plan, and act. And the early papers started off with, the computer, the machine senses something happens and needs to make a plan in order to respond to that sensory input, and then it needs to take action. And this formed the foundation of kind of what we know and call agents today. And this persists, right? This same three-step pattern where these three steps kind of operate in a loop form the same foundation that runs the really advanced agents that we see and use. And so as we're talking about how they work, how they're built, I always kind of go back to this because it really, again, frames just how all of these pieces fit together. Even though it feels magical and feels new, it really is based off of principles and ideas that have been around for a long time. So this is kind of framework number one. The second is agents at their core are really kind of a data pipeline. So the agents take information in some form, they do something with it, they transform that information. Oftentimes it can be with just maybe a calculation now. And I think this resurgence in popularity in agents comes from using LLMs in that transformation step. And that has spurred the wave that we're experiencing right now. But again, it's simple transformation, adding a number, transforming text, something like that, and then loading it somewhere else or providing output. And this, again, Elixir has a lot of primitives and is really good at this process. It has a lot of alternatives, but agentic software, agent flows, really kind of breaks down to this piece. And as I've built agents, I've found this, again, to be a pretty useful concept to keep in mind. So why is Elixir such a good runtime for agents? Now, there's, given this crowd, and we've all used Elixir, I think this is something that may seem a little bit more obvious. But when I'm talking to people outside, why is Elixir a good platform for agents. One, it does come down to how Elixir manages loops and the sort of data pipeline nature of how Elixir fits together. And that really stems from the Beam's approach to concurrency with the actor model and usage of these really inexpensive processes, because we can spin those up and use the process-based primitives to, again, insert ourselves or insert themselves at every step of that agent flow. And that gives us a better set of tools compared to something like TypeScript or Python, as we heard was a popular language for building agents, because we're able to coordinate the work that the agents do through the processes that and kind of the process-based primitives that the Beam provides. So that concurrency really aids in thinking about and building out agentic structures. So as we said, the first reason I would say is kind of this actor model alignment, the idea of thinking about agents and agent software as discrete actors in the system, giving them each an identity through an ID, a unique ID, and then passing messages back and forth, and really sticking to kind of that OTP model of when you send a message from process A to process B, you're just sending the message without expecting any sort of response. That sort of asynchronous nature of message passing that makes the Beam so resilient and so fault tolerant. So second is that fault tolerance, the use of supervision trees for building out agent systems, and the ability to manage little bits of state within each process of those supervision trees, again, makes it really, really helpful and really easy to spin up a large fleet of agents compared to other solutions in TypeScript or Python. As I mentioned, you often see a lot of backflips going into, again, with TypeScript, for example, managing the memory of a single agent runtime, where in the Beam, in Elixir, you can spread that around and have the agents connect with one another through messages. The self-healing, the let it crash stuff, we're, again, for those of us in the Elixir world, have worked a lot with that. But each agent has the ability to, call a little bit of code if something happens, heal itself, and get full, from, or depending on how it's configured, full persistence or how that agent flow was going, and start back over again. And then concurrency. So part of the thinking with agents, and we see this in, if you've looked at any of the cloud-based agent runner systems, they're often utilizing a full Docker container for a single agent running behind the scenes. In Elixir, we have this advantage of building out and having the ability to have, again, multiple processes, and that gives the upward scalability of Elixir-based agents a much higher ceiling than other platforms, like say a Kubernetes or and the Beam itself and how the Beam manages state among those different processes by, again, not sharing state, but then when state is sent back and forth, having messages, message queues operating, and then returning the result, go back to that ETL type flow. I intake an information into the agent, I do something with it, and then I provide the output and send a message out. That lends itself to some really efficient scalability when you begin building out these agents. So where did Jido come from? Jido, 2024, so a little over a year ago, I had just finished up working at a crypto company and was building out a trading bot platform called BotHive. And this was, again, bots. Now, I think what we would definitely call them agents, and the language has evolved a little bit. But a a lot of primitives, listening to an action that happened, bringing that in, running some logic, and then taking action or not based off of the information that I had received. And that was going really well. I had some good success in building and scaling out that platform. And then late in 2024, a project launched called Eliza. This was a crypto project, and it got very popular very quickly. But the kind of key innovation that spread this idea of agents around so well was they released an agent that did a really good job of kind of building out a conversation history, a personality, and then gave a nice TypeScript platform and plugin system that allowed a lot of different people to contribute to this Eliza agent. And it's still available. You can go take a look at it. But it crystallized this idea that a conversational agent that you could talk with, backed by an LLM, could not only chat with you, but it could take action on your behalf. And that was really cool. We hadn't quite encountered or gotten to the place where tool calling was very reliable. And again, this presentation is happening in August of 2025. This was not that long ago, and yet in AI feels like it was ages ago. So that's how it came out. I saw the bot platform. I'm like, wow, like Eliza really kind of makes the bots not look that great. I wanted to build some conversational stuff. So over Christmas that year, spent a lot of my time over break putting together Jido, and ultimately released 1.0 right before the end of the year as, again, a package that you could build agents with. So as I was building it, strong opinions weekly held. What's the philosophy behind Jido? First, the core is data driven. So there's a lot of these defined data structures around the Jido code base that, again, everything kind of derives and follows that basic OTP pattern of, I have a piece of data, I'm going to apply a function to it, and then that piece of data is returned. And that formed really the data-driven core of the entire Jido framework on all levels. And we'll see that as we get into code. I also really kind of made the intentional decision to have no magic, no macros. I wanted to use as much of the just straightforward patterns and base language as possible. There's a couple of tricks and those, but I wanted to make it very inspectable, right? And new agents were a new concept. I was learning what those concepts were, and I didn't want to make it very opaque in working with the agents and moving this data around. And I didn't want anything to feel too magical in that and add any more friction. And then the last piece is I really envisioned, really inspired by Eliza, this idea that the ecosystem would grow. So there's a lot of extension points in Jido. And once an action or an agent is written, you can easily share it. So, concept of what if I wanted to take a specific agent, package it up as a hex package and share it out, that would be possible. And all these tools, all these pieces could compose together to build the agent ecosystem. And we'll touch on some of those today, but not all of them. But this was by far the most kind of interesting decision that I made. And the Eliza put LLMs and the LLM tool call flow at the center of the agent loop. So every iteration, every loop of the agent called an LLM to figure out what to do next. Now, this got very expensive very quickly. That's why you saw a spike in Eliza bots, and then a lot of the Eliza bots got turned off. Context engineering was not a thing. We're all learning about this still, but you got to rewind back. And I, again, made the intentional decision that you are not putting LLMs into that core workflow. So the core Jido package doesn't have any AI, doesn't have any LLM in it. It's just the key data structures, the key flows to be able to create these agentic flows. And your own brain, your own thinking, your own reasoner can be simple coding logic. And there's a world of classical AI algorithms out there, behavior trees, hierarchical task networks, A-star type pathfinding stuff. I wanted to be able to make sure that Jido supported those categories of planning algorithms as well as LLM planning algorithms. And again, this was by far the most opinionated decision that I made in building out Jido. So let's get into it. Basic mix install, 2 key packages. And as I mentioned, the LLM stuff. So Jido 1.2 is the current release. Jido AI is undergoing a complete overhaul. So definitely use the branch that's listed there. And then I've, through iterating over the last year, have split out 2 kind of component packages, Jido actions and Jido signals. We'll get into what those mean, but they're included in Jido itself. So you really only need the top 2. Top 1 if you're building a non-LLM agent, the top 2 if you're going to build an LLM agent. There will be full Hex releases where everything will get synced up to Hex 1.5 or version 1.5 on Hex. So watch for that. And that's how you install it. So core concepts. The first thing is that as agents evolved, they needed a better and a little bit more enhanced way to communicate. And I ultimately opted to build out a concept that I call Jido signals. Jido signals are the messaging envelope that represents any message that moves through the Jido system. It's based off of cloud events. If you've ever used a CQRS system like Commanded or envelope patterns through RabbitMQ, AMQP type stuff, same idea. It's a simple Elixir struct called a Jido signal. There's a lot of ways to define and build these out, but they're, again, defined by their type. We take advantage of some of the extra fields defined by that cloud event spec, so we can source what agent they came from, and then a data payload. And that data payload is a map. These can be converted to JSON, et cetera, et cetera. But this is a key kind of foundational concept that's used all across Jido, and that is signals. We'll see those later on. Second is actions. So our action is a module that's defined that implements the command pattern. It has to implement this run arity2 method that the first parameter is a map of params, and the second is a context. And then that run method returns with an OK or error tuple something that new data. So these are your transformation functions. They're composable. These are the building blocks of Jido. So everything is an action. They are testable, and that was meant, so you could define this run method. You can call them directly, make sure that they work as expected. And they all take, depending on kind of the runtime and setup, a input schema. So defined using nimble options, that's what's defined here, along with metadata that describes kind of what this action does. So as Jido evolves, we needed additional metadata for a simple pattern that brought consistency, go back to that composability principle, for how activity or how action was taken across the Jido ecosystem. So one nice side benefit is that it's a one method transformation to convert this to an LLM tool call. And this has compatibility with LLM tool calls. We have a whole kind of body of Jido actions that's slowly building across the ecosystem. We'll take a look at some of those today. You can define your own very easily, but they also, actions can kind of compose other actions. So I get asked a lot about workflows. Workflows are simply an action that calls a workflow, and then that action itself underneath calls several workflows or several other actions in sequence. So it's just code. That was the idea. It's meant to be, again, straightforward and simple. This is your building block, nothing more. And there is a bunch of kind of extra features here that we're not going to go into. You could obviously run, it's just a module, greetuser.run, and you can run that action directly. There is another tool that ships with Jido that when the action is executed by the agent itself, it is executed by Jido.exec. And Jido.exec wraps the action in timeouts, in you can make it asynchronous. You can do all this different runtime stuff to make execution of those actions more reliable. And again, it's all based off of the same kind of command pattern, the same foundational action. And so this gives us a floor to build from. And one of the first things you do when you think about what your agent needs to do is list out all the actions and then build those using this pattern. So can't mention, again, the LLMs are all around this stuff. And I do want to mention it. As I said a little bit earlier, Jido AI is undergoing this giant transformation right now. The first version, so it was an add-on package. The first version used third-party libraries like the instructor library, like LangChain, to do a lot of the LLM calling when I started months ago. That has now changed, and there was a lot of extra code to convert actions into tools, convert those to LangChain formatted tools, call them, etc. That has now been squashed, and we've modeled the new Jido AI off of the Vercel AI SDK, which is by and far, I think, one of the best API surfaces. And again, building out the ability to call pretty much any LLM that you want, to generate text, to stream text, to stream an object and do all the structured data extraction that you need, on and on and on. These direct methods, the generate text method, this is, again, the API surface that just comes with the module, but then obviously this is available as an action as well. So this is how your agents call an action, or you could write your own LLM action and utilize the generate text method, depending how you want it. I didn't mention this up front, but Jido was really designed as an SDK. It's not full agents, it's not batteries included type agents. You have to be able to put it all together, which is why we're giving the primitives the pieces and looking for the best surfaces and patterns to build some stuff with. So we can talk about this in the Q&A if you're interested in the LLM stuff. That's where all the innovation is happening right now. But today's talk is mainly going to be kind of the non-LLM stuff. So next step. So getting to the good stuff. Stateless agents. So there's a distinction, and we'll talk about stateful agents in just a moment. But as I mentioned, that data-driven core of Jido is a data-driven agent. So it's an agent struct that, again, you follow this use pattern, you define the name, the schema of the data that agent should hold, and then the allowed actions that agent can execute. And you simply follow very typical Elixir patterns of calling a .new method. When you call that .new method, you pass a unique agent ID, so you can instantiate multiple copies of that agent. So again, the thinking is, I'm going to have my agent in my system. I want to spin up 100 hello agents, and I'll be able to use those independently and distinctly across my entire system. That agent holds state. So I'm passing in my initial state as the second parameter. And what you get back is a struct. The unique ID, that state, then some metadata to handle how that agent operates internally and what that most recent result is. And so there is an instruction queue, so you can plan an agent and begin throwing, passing around, a data copy of that planned agent using an Erlang queue, and have it queue up the instructions that should execute, and then the actions that are allowed, dirty state, and then what that last execution result was. So the core module, Jido agent module, provides a couple of methods that mimic back all the way to that kind of sense, plan, and act flow. And that's where the API was, again, really built around. So we can build a new data-driven agent. We take that agent struct, we can set the state for that agent by passing in a map of parameters. Now, this is validated against the defined schema of the agent at runtime, and you'll get an error if for whatever reason that doesn't validate. You can also turn off validation, of course. Then there's this distinct plan step where you pass the modules for the actions that you want to queue into the agent as the next executed action. And there's a lot of kind of expansion points here for customizing this step. It takes a list. There's another data structure called an instruction. This is technically passing a list of instructions, of which one form is simply the action with no parameters, but you can, pass an instruction into the plan, and it will execute with predetermined parameters, for instance. And then you run that agent. And there's a lot of options here as well, so I'd encourage you to investigate this. But the most simple version is, in this case, the run method will simply execute and return the results for one execution of the greet user action on a 10-second timeout. So again, lots of ways to configure this, but this is that fundamental loop. And why expose these methods? It's all about testing. Like testing, it's really important to be able to test the agent, to get the state back, to introspect what that state should look like, and have a way that you can build trust and reliability of the agents you're building before you go too fast and things get a little out of control. So there is one sort of developer, nice, sugar-ish, but it's this command method. Command just wraps all three steps into one simple method, and we'll see this. So it builds. So we need to pass the agent struct as the first parameter, the action that we want to take, and then the data to pass in. So this sets the name to Mike, greet user, and then the agent result will contain hello Mike as the most recent agent result, because it returns the full agent struct, and then you can build and iterate off of that. So that's stateless agents. No runtime lifecycle, no gen server lifecycle yet. So moving on to stateful agents, and this is where gen servers come into the mix. Now, there's a little bit of magic here, and this was it was too good to not do this and make it work this way. But the same pattern, I'm going to define my custom agent, my hello agent. I'm going to use Jido.agent. I'm going to name that agent, and I'm going to list out what actions are available with the validation schema for the parameters involved. Just like the set, plan, set, plan, run, and command methods, I can call start link on this agent, and it will return a PID to a process that was started and kind of built around this agent struct. So it creates a unique copy of that data struct, embeds it in a gen server that's called Jido.agent.server, and makes that available and starts that in your system. So in this case, it's not linked to anything, but you can then call methods on that gen server just like you would, again, another gen server, but it's a unique Jido agent that gives you a whole bunch of other features that, again, we'll talk about a little bit. The key here is that this direct, so the Jido agent server has two primary methods that you use to interact with it through messages: call and cast, again, following the gen server pattern. And these all take signals. This is where the signal comes in. And so we have to send in a type of a signal. This is the greet user signal, internal to this hello agent here. And this isn't shown in this case, but that greet user would be mapped to execute this action, passed with this data payload. And then the call method returns the result itself, because the agent struct inside the gen server is just kept in the state of that gen server. So you don't have to worry about all that other stuff. You don't have to kind of manage the data structure externally, but you can, if you're writing tests, you can write tests around this and then simply embed it in a hello agent gen server. So, okay, we're going to get into a demo, and these demos, I'm going to make sure I can see the screen, and feel free to ask questions if there's any questions along the way, and we will, we'll take a look at the demo here quick. Okay. I'm going to stop presenting here. Shut that down. Share my entire screen. And what I have done is I have built out a calculator agent. So as we saw in the example in the slides, this is the calculator agent. So it supports simple math calculations: addition, subtraction, multiplication, and division. As you can see, we define our module and then have a little bit of documentation. This agent can be started as a gen server itself. And we have kind of our use block to define the agent. We have some agent memory or schema that we can work with. And then in this case, we override the start link method. Jido agents define and offer that, you can call it just Jido agent.start, but in our case, we're overriding it. I take in a number of options and we verify that we have a name in those options. I then set our initial state to blank. And then I have a number of default options here. So the first default option is the name of the Jido agent module that is being used. So in this case, we're just using the calculator agent, and the Jido agent server that we call down below knows that that's the type, that's the agent struct that we want to embed. We can set a log level. We'll look at that in a minute. But then there is this idea that we didn't touch on, and that's skills. So it gets a little tedious to package a group of actions and their shared behavior into a group of functionality. And so this goes back to that composability principle. There's a concept called skills. It's another simple data structure that allows you to group a bunch of actions together and make them shareable. So agents, instead of having to list out a whole bunch of actions, you can just say, this agent supports this skill, and the agent inherits all that functionality right here in the startup. So state manager is the ability to modify its internal state. We don't use that totally in this example yet, but then I pass in and allow override of my server options, custom ID, what that initial state is, and then here's the override. So in our case, our calculator agent start link, very much like you would a gen server, returns Jido agent server start link and passes in those options. And this is what makes it a stateful agent. Going down to our first method. So again, very, very similar pattern to the way a gen server works. Instead of having the handle callbacks, you have actions. And then the idea is that your agent, you define your public API. So we're going to define our public API for the add method, and we'll see how that works. Or you can see an example of it right here. I start an agent, I call PID with adding two numbers, 2 + 2, and then I resolve that PID depending on the agent reference that's used. You can use names and all the normal stuff. I then create a signal. Now, the signal is that envelope that maps the string arithmetic.add. And again, we're going to skip over how skills work right now, but this happens within the skill. So arithmetic.add is mapped to the arithmetic add action with this payload. So this signal, again, is just a data structure. And then we call Jido agent server call with the PID, our signal, and then a default timeout. That creates a message from our callee process, packages it as a signal envelope, sends it into the process, the Jido agent server process for our PID, works through the process of queuing this signal, executing it, then calculating the result. In this case, it's simple addition arithmetic, and then sending the result back to us. And then we get the result right here or an error, and off we go. So we're going to take a look at how this works. So I'm going to have a script here that I'm starting the agent. Right now, I'm going to keep our log level at info because that's the default, but we could override that and then do some addition and return the result. So can everyone, is that big enough on my screen? I'll take silence as a yes. Okay. So I'm going to run this script that starts our agent, brings the PID back, and then calls the add method. And we'll take a look at what happens here. So I have debugging, lots of fun debugging stuff turned on. We initialize the server with ID complete test, log level info. We can see that the signal was sent. And what happens here is that a signal was emitted by the agent. And by default, that signal is outputted to the console. So the signal Jido agent event.started from, that's the source, agent complete test. So there's your ID. And that was emitted, and because it had nowhere to go, but that was our signal that the agent booted up and got started. It then receives a request. This is now our add call to execute the Jido tools arithmetic add. That's the action with parameters value 2 + 2 operation add. So underneath the covers, it uses this operation idea. And then there's the context that's passed into the action. And then the result is emitted with Jido agent out instruction result, there's a that might be a bug. We'll see. I'll look into that one. But the result is outputted saying that it had the result of 4. I think that should be agent complete test, but we're going to turn on debugging and take a look a little bit more. So I'm going to dial up debugging, and we're going to run the script again. And so we can see a little bit more. Each signal has a unique ID, so that might be the signal ID. Yeah, that was the signal ID. Just the log level is, the log line is a little bit odd. So again, information on that signal being emitted by the agent, letting everyone know that it got started, starting execution of Jido arithmetic add. There is a way to validate the output, but we didn't have validation for the output turned on, so that succeeded. We successfully finished execution, and then it emitted the signal back out. But in this case, the source of that, yeah, we'll have to look into that a little bit more. But the signal, we knew what signal went in, and here's the signal that comes back out, and then here's our result. Any questions or anything on that so far? Oh yeah, I'm gonna keep going. There's several other methods in here, and as you build out your agent, as you create the agent inside your system, they all follows the same pattern. Jido signal new. You can create your own actions and define what that looks like, and we'll take a look at that in just a second. But the arithmetic skill allows us to expose these actions. The agent itself maintains state. So we're going to go ahead and rather than bring back the full, I want to show state. Here's the state of the Jido agent server. Once again, data structure, what the current signal is that we're processing. There's a queue of those signals inside the agent server as well. And then in this case, each agent maintains a router that is able to route this signal type to a Jido instruction. And that's how the actions get executed. Dispatch is dispatch is a utility that is able to take signals and send them various places via a tuple-based kind of definition list. And so in this case, this is why we're seeing those signals being dispatched to the logger. The registry that we're using, the total queue size, you can pause an agent so it stops, it'll accept signals, but it won't execute them, our log level. And then here's the agent struct that lives inside that gen server with the actions that it's allowed to execute. And finally, the current state of the agent itself with the latest result. There's our addition. And then here's the incoming ops that was used to start the agent. You can see how these get expanded out. There's a lot there, a lot kind of scaffolding that gets built around this basic struct for the agent itself. What's nice, though, is that you can easily define your own agents and build upon this. So jumping over to our next example, the weather agent, couple of things this weather agent uses some new tools that I haven't released yet, or I think were just released this week. They use the National Weather Service API that call a direct weather tool. So I wanted to show this idea of a custom routing table to send signals into the agent. And this is kind of the main difference in this example. So any signal that matches type weather will execute a Jido instruction that embeds the action jido.tools.weather. So this is how we take the signal of weather and map it to the Jido tools weather action. And when we call and send a signal in, as we'll see in just a moment, the agent itself handles executing this action with whatever parameters or data payload was added on to that signal payload. So we can say get weather. Once again, I'm going to resolve the PID based on the name, the ID, the PID itself that comes in. I'm building up a custom signal to go get the weather. There's that string that maps to the routes, the routing table up above. Here's because this is our public API, I can pass in a location, and we're going to say it's format text testing is true. So in this case, it's not hitting the actual API. I then send that signal into the system just like we did before, and we get the weather back out. So let's look. So our weather testing script, start our agent, call it weather test. Let's get the weather in Montreal. See if that will work. Again, I think this is using the test version of the weather tool, but we can see the flow again, initializing the weather agent, emitting a signal. That signal was started. We're executing the weather tool with these parameters. Started the execution, output validation succeeded, finished execution with returning the result. It emits a signal to respond and send the result back. And oh, that didn't take. I think this is dummy data in this case, but I doubt it's. You have to tell me what weather is there now, but the number didn't change. So that's how that works. You can kind of see and build on this where it's be very easy to throw in a LLM call. There's ways as well, and I'll tease this one last piece. In our action, when we build a custom action, the way that you achieve the kind of looping with these action calls is through a concept called directives. The agent itself executes the action. And so the action can't affect the agent state directly, and we don't want it to. We want these things to be applied in order. So the schema, when you return from an action itself, you can pass a third parameter to the return tuple called directives. Directives are a single item or a list that in this case, what this does is it creates a list of special instructions that says, after you're done executing this action, in queue the next action to run, and you can achieve the LLM looping tool call. The execution flow is maintained as the agent proceeds with the parameters, or you can pass params into it. So with that, that is it. Oh, I do want to show this. We did our weather demo. So what's coming up? So as I said, I'm working hard on getting the 1.5 release. This is you push hard, you're embarrassed by the 1.0 release, but you got it out there. 1.5 is, I think, what I wish Jido was when I skipped 1.0. Lots of learnings along the way, lots of building agents along the way. There's a lot of just quality of life things, and this is the release that I'm getting to the point I'm very proud of in terms of what it can do. Complete overhaul of the Jido AI module. The abilities and just what you can do with LLMs has exploded as well. So full open router support, just much more built out to be able to make LLM calls. The big kind of innovation there is not only being able to accept streaming output from LLMs, but then the LLM tool calls are natively integrated right into the Jido action system. So it just loops and does it all as you would expect. And then, of course, building out the library of sensors, skills, and tools. So issues and PRs are welcome. There's not a lot of kind of issues built out, but there will be more as we build out what Jido is capable of, and people using it. I do have a Discord that's pretty quiet, but it's where we talk about Jido. There's also a Jido Slack channel on the Elixir Slack. So with that, thank you very much. Really appreciate it. And yeah, that's the GitHub of where it's at. So